Hello, I am David W. Parker. This is Programming Today I Learned, 3D Math Series, and I believe this is episode 8, yes, and we're going to be looking at matrices, part 2. This will be a very short episode. We're going to be talking about transposition of a matrix and scalar multiplication. So what is transposition? Transposition of a matrix, an R by C matrix, is denoted by MT, is the C by R matrix where each column is made up of the rows of M. So mathematically, M of ij transposed is M of ji. So it's kind of a mouthful, so it's easier to look at examples. So let's go right ahead. So you can see here's a small matrix here where you can see the row M11, M12, M13 becomes the column M11, M12, M13. And similar, the next row becomes the next column here. So you can see that this column becomes this row, and this row becomes this column. So a specific example of this, you can see the square matrix here. The row 3, 4, 2 becomes the first column, 3, 4, 2. The next row, 7, 9, 1, becomes the next column, 7, 9, 1. And 5, 6, 8 becomes the column 5, 6, 8. You should note that the diagonal 3, 9, 8 stays in place the whole time. Vector transposition is basically the exact same thing, but a row column becomes a a row vector becomes a column vector, and vice versa. So if you were to transpose this 3, 4, 2, it would become this row vector as well. So what are a few notes about this? Obviously, if we take the transposition of a transposition matrix, we haven't done anything else to it, it becomes the original matrix again. You can see that in this example here. If we transposed this original matrix and we have this new matrix here of 3, 4, 2, downward, 7, 9, 1, 5, 6, 8, if we were to transpose this again, we would get this original matrix on the left-hand side once again. Similarly, if you take the transposition of a diagonal matrix, and this is not a diagonal matrix, recall that a diagonal matrix has all zeros in every position outside of the diagonal. So if these were all zeros, the 7, 5, 6, 4, 2, 1, if those were zeros, if you were to transpose the matrix 3, 9, 8 in the diagonal stays the same. So transposing a diagonal matrix keeps the exact same diagonal matrix. Multiplication with scalar is obviously very simple. It's just like with a vector. So if you have the M matrix here multiplied by k, you'll end up with every element being multiplied by k. And that's basically it. So a nice, short, easy episode this time. If you like what you saw, go ahead and subscribe. Like this video, share it, give it a thumbs up, and sign up for my newsletter at programmingtil.com. Have a great one. Thanks.